Hi, my name's Michelle Pagani, and we're going to do the bright ideas for bringing the 2017 solar eclipse into your classroom. I've got some products and some great ideas to bring this concept to your classroom. Let's start. The first thing is if everyone would please *6 to mute if you're using a landline, or just mute if you are on a cell phone. Okay? Questions can be submitted through email, right, Peter?
Email or the chat feature.
Email or chat feature.
Or unmute *6.
It should have been in the email that you got when you signed up. Okay? All right. So let's get started. The agenda today is first some basics about eclipses. The second thing is the safe viewing practices. And the last one is ways to incorporate this eclipse into your classroom lessons. There. So the first differences are, what's the difference between a solar eclipse and a lunar eclipse? The solar eclipses, there's 4 listed there. There is a partial eclipse, an annular eclipse, a total eclipse, and a hybrid eclipse. It depends on where you're found in the penumbra and the umbra as to which one you're going to be visualizing. The partial is usually on the outside of the, when you're in the penumbra, which we'll talk about in a few minutes. And the annular is when you see most of it covered, but you see basically a crown around the outside of the sun. The total is what we're experiencing in certain parts of the US in August, where it completely blocks the sun. And then the hybrid is the weirdest bird of the 4 of them, where you see a partial or an annular for part of it and a total depending on where you are in the larger viewing area. All right, as you see there, I've tried to put references for each of the schematics that I found. You see here that it's hard for me not to point to things. So you see here that there's 2 examples there, or 3, and you can see how a total one is formed when you're in the umbra. So there is like a cone shape where the middle, in this case, the moon is blocking the sun. You can see the really darker shaded areas on the PowerPoint. That's the umbra. That's where you're going to see total darkness. And the outside is the penumbra. And there you're going to see a partial. If you see an annular eclipse, it means that you've actually, the umbra has not touched the surface of the Earth, and you can see that there's a little bit of a little triangle at the bottom there, and each of them are labeled to make it easier to see. Okay? Along with this, a lot of people are going to ask things like, how many solar eclipses are there usually? I mean, why is there such a fuss right now about this total eclipse coming? It's because total eclipses are more rare, and they can happen and do happen all over the Earth. So we are excited in the United States because it's one of the few times that at least a portion of the United States, because it goes all the way across it, that we actually experience the total. Sometimes the total eclipse can be in the ocean and no one's going to see it unless you're on a boat, obviously. It might be in the Antarctica, so places that aren't inhabited. All right. There's about 2 to 5 solar eclipses a year. And like I said, though, they can be any of these partial, annular, total, or hybrid types. The other one I know. And when there's a total eclipse, another interesting fact that the students would be grabbed by is that once the sun gets covered up, the temperature on the Earth, where that total eclipse is, can drop by at least 20 degrees. So it's significant, not only what you're viewing, but what you're feeling as well. Let's see, what else? Lunar. So the lunar eclipses are where the Earth is blocking, and we'll go through all this with each of the models to make it easier, but it's where the Earth is blocking the moon from the light from the sun. So the Earth is in the middle of the moon and the sun, and so then you end up where you can't, you don't see the moon for a little while, right? There's also, in lunar eclipses, there's partial and there's total as well. An interesting story that students would like is that in 1504, Columbus actually was here in America being fed by the Indians, Native Americans, I guess, and they were getting kind of disgusted and didn't want to feed him anymore. So Columbus was not being fed. He remembered when the lunar eclipse was going to be. He made a big hullabaloo with the Native Americans and said, I'm going to take the moon away from you. And then the moon went away, and he said, I'll bring it back if you're going to feed us. And then they agreed to feed him, and the moon came back in the couple of hours, and then they started feeding Columbus again. So students will be excited about things like that. Some other differences between them are that solar eclipses go from, they're different amounts of time. A total eclipse is usually anywhere from 1.5 minutes to up to 7 minutes. So when we talk about this, it's a very short time span that you can catch the actual thing happening, right? The one in August is supposed to be for 2 minutes and 40 seconds. So that's when the only time it's going to be completely dark. Lunar eclipses, they last usually for a little longer period of time, basically because Earth is a bigger object in the sky, so it blocks the sun a little bit longer. So that will usually take a couple of hours for the lunar eclipse to complete. Right? Okay. Let's see to the next. Thank you. So the total eclipse that's happening in August, as you can see, all total eclipses only happen during a new moon. So when you teach the moon phases, the new moon is going to be when the moon is on the outside. I'm sorry. Let me get this right. The moon is going to be on the inside, and we'll do that with the planetary models in a minute. Also, the other thing that enables a total eclipse to happen is that each of these orbits, so the orbit of the moon around the Earth is elliptical. So it's not a circle as sometimes students think. It's actually an ellipse, so it's an oval. So there is a point at which the moon is closer to the Earth, and there's a point where the moon is further from the Earth. And the one where it's further from the Earth is the apogee, and where it's closer is the perigee. And then the same thing with the Earth going around the sun. It's also an elliptical orbit. And in that case, we talk about it being the aphelion and the perihelion. So you think about a peri or perimeter being close to something or next to it. So the peri is always the closer one, and the appa is farther away. Okay? So what I've also put here is when the next one is going to occur, because students are always going to want to know that. And as you see there, it's April the 8th in 2000, see, I wish I could, 24, thank you, in 2024. And as you look at the path there, it's sort of opposite of what it is this time. We'll show it at the end, but it's going kind of the diagonally across the United States up this time instead of down, which is the other way. Okay? Let's see. I think that's, it's usually only a few miles wide, say, you know, like 30 miles wide or 40 miles wide that you can get this total eclipse. Now, there will be other total eclipses that are not in the U.S. between 2017 and 2024, but since we're in the US, that's what we care about right now. Right? That's kind of the background of eclipses and how they happen. The next one is safe viewing practices. So you never should look at the sun because you'll end up burning your retina and you'll end up going blind, right? So I took this information off of NASA. You'll see it there listed on the PowerPoint at the bottom. It shows you where I got it. It is, as you see, it goes through and it tells you the different parts of it, the partial, where you see the beads, then you see a diamond ring as it just starts to close, and you can see them all illustrated there. Then totality, where you will see just kind of the corona of the sun, and then at the end, the final stages, it goes in reverse. As you see, in each one it says glasses on, except for during totality. But even during totality, then to be safe, you should leave it on, but it won't burn your retina during that time. So what am I talking about when I say the safe viewing? There's a few different ways. One of them are these fancy, easy, economical glasses. They are with a metallic coated mylar, similar to balloons, and they're just cardboard, so they're inexpensive. They are called Eclipse shades for a reason. If you try to look at almost anything else, you'll run into walls because it's so dark, right? But you can demonstrate to students, and I'll show you in a few minutes how to demonstrate why these are important, all right, before you even go to see the eclipse. All right, can I see the next? So here are some of the options that you can use to view the eclipse safely. The first one were the glasses I showed you. We have some kind of goggle-looking things that are listed there also. And all of these products are at the end of the webinar. And another option are these binoculars. And they have a solar filter on them so that, as I say, you can't really see anything when you look through them unless you were going to look at the sun. All right? Okay. We're going to talk about some why you might want to look at the sun when there's not an eclipse also. So we have binoculars, we have telescopes you can look at with solar filters, and then the last one is you can make a pinhole camera. You can see it illustrated there in the middle bottom of that slide. And it's a way of taking a cardboard, making a hole, and being able to look at the sun through that hole on the ground. You have to play with what the right distance is and things like that. All right? Okay. So that's how you do safe viewing, and that's the equipment that you can use. So how are we going to use products or these products now and in the future, not only with just eclipses? And so if you wear these glasses, you can actually, you don't want to do this without glasses on, you can turn on different wattage light bulbs, and you can actually see the filament inside, all right? And you can show the difference between how strong something is and how weak something is, and it doesn't hurt your students' eyes. Okay, that's one use for these. Another use is more visibly seen with this piece of equipment. And this is another way that you can view the eclipse, but you can also view it on any day that's sunny. It's called the sun spotter, okay? And it has mirrors in it, and it has a lens on this side, and you direct the lens at the sun. Let's pretend that one of our lights is the sun. It comes through the lens, and above that, and I'm going to show you because it's hard to see. Can you go to the other camera? You see this little metal stick? So the way that you line this up is that you put it toward the sun, and then you can rotate it along this wooden thing. Hold on. There we go. You can rotate it so that you can get the right angle that where that metal stick is, you get no shadow. Once you get no shadow for that stick, then the sun is going at the right angle and the mirrors will project it right here on this white piece of paper. And what's so cool about this product, this item or easy way to see it, is that you'll see the sun and you actually are able to see the sunspots. Now, some days have more sunspots than other days, and the way that you can find out how many sunspots there are supposed to be that day or how many there are that day, they calculated all this, is on the PowerPoint below where it says observe sunspots without damaging your eyes, there's a website. And that website, if you click on it, it will tell you how many sunspots are found that day. Okay, so you'll see them more as, it'll look somewhat like the first slide, but it really looks more like a white sun on here, and there'll be black little spots if the sunspot is big enough. Now a sunspot is it's actually, when we see it as a dark space, it's not really a dark space, but what it is it's these, it's a magnetic charge where it's in pairs. It has two different polarities on this pair, and it puts kind of a kink in the convection of the sun. So what it does is it kind of builds up, I want to say almost a pressure there because the energy can't flow as well. And then there'll be a flare, a solar flare, and you hear about solar flares, and a coronal mass eruption where these ions and plasma and electrons and all that cool stuff that's been trapped in the sun ends up getting released, and in about a day to 2 days it will actually reach Earth. And then when it reaches Earth and it's around the poles, you'll start seeing Aurora Borealis with the really pretty greens and blues and all of the colors. Or if you're in the south, and you're going to see the Australia's Borealis. Okay, so they talk about Aurora Borealis. We're in New York, and sometimes you can actually see it here. Better if you're in Canada, or at least closer to the poles. So this product is kind of cool because it does, you could trace it over many days and see how many sunspots. And then if you have a lot of activity, if it's a high activity, then you could check and see if there's Aurora Borealis going on as well. Now, the aurora, or the way that you know whether it has a lot of activity or not is that, like I said, that website, and it goes on a solar cycle, and the solar cycle is 11 years. So they can determine based on when it is, if they expect to, how many sunspots, and you know if the aurora is going to be, you know, a great show or not. Sometimes you'll hear them talking about that. All right, so that's another way of looking at the eclipse safely, but then a way that you can use it in the classroom afterwards. Another couple of things you could catch if you were at the right time. If you had your sunspotter and you saw something similar. Now, this is a composite. Both of these are a composite picture, but as you can see on the top one, it's actually, you see that the space station going across the sun. So you wouldn't see it quite like that. You would see one dot. And if you leave the sunspot set up, you will actually see the sun move, because the sun, well, the sun's not moving in the sky, obviously. We are. But as we move, it appears that the sun moves. So you'll actually see that change on the sunspotter itself as well. So you might see this space station, and you might see it move across the sun. Likewise, Mercury being closer to the planet closer to the sun, Venus also, you'll see this Mercury transit. Because it's closer to the sun, you see it more often than you would see something like Venus, because its orbit is smaller around the sun. Okay, so those are some other cool things that if you, they predict and you can actually see when they're going to be and use that in your classroom for interest.
Good question in regards to sunspots, is there a minimum or maximum to expect?
No, sometimes there's zero. And it really depends on how large the sunspots are, because the sunspots are anywhere from, say, 1 kilometer to 1,000 kilometers. And the only ones that we're really going to see on Earth are going to be the ones that are large, like the 1,000 kilometers. They're bigger. A lot of them are even bigger than us. Or not us, but the Earth, I should say.
A comment that they heard there's also a 90-year cycle in addition to 11-year cycle.
And there may be. I know about the 11. I don't know about the 90. I think there's so many cycles because you've got your lunar cycle. You've got, yes, I'm sure there is. I'm not sure what the 90 is, though, myself. I'd have to look that up. But if you email me, which you'll see my email later, I'll look it up. All right, so some other ways that we can show classrooms things, let's see, is looking at a device similar to this, which is an orbital planetarium. And if you want to go to the other camera for 1 second, thank you. You can see here that the bottom is labeled with the months, it's labeled with the zodiac signs, and it's labeled with the seasons to make life a little easier to figure out what's what. All right. And it's motorized. Now, this one is a more economical version than the second one I'm going to show you. So it does have some non-optimal ways, but it does give you essentially what it needs, which is the moon, the earth, and the sun. The one about this is that it does take you through and show you how the earth is tilted according to this, right? You can see that. So you can talk about rotation, you can talk about revolution, and what I've done with some students that I was teaching rotation and revolution that had trouble with it is that I always like to make a little bit of a fool of myself. So if I talk about rotation, I put a T and then I spin and say this is rotation so that they can tell the difference between that and revolution, then, walk around something to show that. All right, so this shows revolution and rotation. The only thing is, one problem with this one is that it is a circular orbit instead of an elliptical one, so that's an issue. And the moon, you have to move, but you can show that the moon actually goes around the Earth at the same time as the Earth is going around the sun. Now, this is an illuminated one, as you can see when I put it that way, probably. It is illuminating onto here, so you can show, when the moon gets in the right spot and is a new moon, and this is a new moon because the moon is between the sun and the earth, you can see that the shadow is cast there. And if you cast it in the right spot, they can kind of predict where is that total eclipse going to be. Okay? All right. So that one is there. And to go along with that, we have a larger product, and that is this one. This one's a little fancier because this is motor driven, so it actually will, you can put the light on and it will actually spin on its own. So it gives you a relative speed of rotation, revolution, and the normal forces. Now, the difference between this one And the other one too is, remember I said that that other one was a circular pattern or circular orbit? This one is actually an elliptical orbit because it does have this little arm that rotates a little bit. Okay, this is actually to represent Venus, just to show you that there are other planets that are closer to the sun. Where Mercury went, I guess it's too small in this case. No, not really. They just left that one out. Also on this base, it's similar to the other one, that it has the months, it has the constellations, and it has the seasons. And you can stop it at each place and say, so why is this winter here? Why is this summer here? And of course, it has to do with what's the tilt and what is actually pointed toward the sun at the time. Okay? But this one is an easier way to do the eclipse because as it moves around, you can see it there. The disadvantage of this, and you can certainly have students come up with this, is that if this were accurate, then we would have a total solar eclipse every time the moon came between the sun and the earth. But, and you can explain this to them, the moon is actually not on a perfect revolution. What it does is it has a 5-degree angle, so that sometimes it's a little bit above the earth, sometimes a little bit below the earth. Okay? All right. So this is kind of a cool model because it takes you through each revolution, each rotation. Okay. Now, I'm going to get this out of the way so I don't trip. Oh, the other thing that they can do with this model that I forgot to point out, and I guess I should, is that since this is an elliptical like it should be, you can actually have them measure from the sun to the earth at different points around the circle, and they can figure out where is the perihelion and where is the aphelion. So where is it closest to the sun and where is it farthest to the sun. And that will always kind of be a perplexing problem to people that live in the northern hemisphere like us, because we think, or kids would think, students think, that the hottest time of the year is when we're closest to the sun. But what's really cool about that concept is that the when we're closest to the sun is in January, and in January you would think it would be warmest. Obviously it isn't. For the people that live in New York, we know it snows then. And so it's a little kind of a conundrum to them that they have to explain, they have to figure out how that all works. All right. A couple of other products that are cool. Let me see if I've missed anything. I'm going to look at my little cheat sheets here. Moon phases. You can also use this for moon phases because when it is, I guess I'd have to turn this one on, wouldn't I? I'll do the other one because it's easier. I can move that one without damaging it. All right. So when it is here, when it's in this position, it's going to be a new moon. When the moon comes furthest away, it's going to be the full moon. And remember, we think that it's blocked, but because of that 5-degree tilt, you're going to end up seeing it illuminated sometimes. It also, when it's a full moon, it actually follows kind of the path of the sun. So at sunset, it comes up and goes down at sunrise. And then when it's in new moon, sometimes we don't even see it because as it rotates or as it revolves around the earth, it's in different places depending on the day and the time. Okay.
Some comments. The eclipse eclipses happen 14 days apart from each other and occur closer to the vernal, equinoxes, so around spring and fall seasons?
Sometimes, yes. Yes. They consider sometimes them to be associated with it, yes. Is that the only one? Or did you say another one?
She also said eclipses 14 days apart mean 14 days after a solar eclipse there will be a lunar eclipse and vice versa.
Oh, because it's going to the other side, basically. So the moon revolution phase is 27 days, so that makes sense that it would be on the other side, so it would be in position to be the opposite, to be a lunar eclipse. So that makes perfect sense. Okay, so there's two other things that I wanted to show you. Along with this, when we're talking about seasons and eclipses and sun and global warming and all the things that can go along with this, is a product that is called the Sun Seasons and Constellation. So if you want to do it even more economically, I said that on these bases, they talk about the different constellations. What you can do is tape up constellations around your classroom or around the model. Here's the Earth. It's on the tilt that it normally is at. I think it's 7.1 or close to that. We have these thermometers that you can use for fevers. They're called fever thermometers. And you can put them at different parts of tape them to different parts of the Earth. And then take a lamp, shine it, and wait for a little while, wait the day, so to speak, and see where the angle of insolation is greatest so that you can indicate why it's summer, why it's winter, and so forth. So they'd be taped. I didn't tape them, obviously. The kit itself does come with a lamp instead, but since I was using this before, it was easier for me to use that now. All right. Another cool product that teaches kind of paths of the sun and moons and all that good stuff is our solar motion model. And our solar motion model is good to show how the sun, the path of the sun in the sky over the course of a year and how it changes. And if you look at, I'm going to move this for a second. You can see that it shows you latitudes, and on the other side, it shows you the months. So since this is June, and we're at about 42 degrees latitude, then this is the sun. So as you can see, this little, thank you, sorry. Do you see this little metal thing represents the sun? So as it goes across the sky, and of course it's going to go east to west, right? You can see how that angle is at that time of the year versus in March going here, or January, the furthest south, and why in our particular latitude it's always south. Okay? You can try different latitudes and depending on where you live to show different paths. Okay, and I think next, I believe. So on our website under teacher resources, and I've shown a snapshot there, and then I've shown you what is there once you get there. It's called the Great American Total Solar Eclipse. You can see in the red, it shows you the total eclipse area, and then you can see the what's listed there, how much of the eclipse or how much of the sun will be left when the eclipse occurs. You can see that it varies according to what part of the United States that you're in. Okay? And I think the next one's products. Am I right? Yes. Questions? This is my email address. If you have any questions or if you need the presentation or you need science help questions, that's listed right there. And then if you go to the next one, I have a bunch of products there that we've talked about. Some of them I've shown you, some of them I haven't. There's a travel scope, which is basically a telescope. Those binoculars that I talked about. Poster and the glasses, these kind of glasses. And the one with the goggles is the observing kit. If you go to the next slide, please. The Orbital Planetarium Illuminated was the first one I showed you. The motorized illuminated planetarium is the second one. The Sun, Seasons, and Constellation is the one with the globe and the light and the constellations and the thermometers. And then the last one is a bundle that we offer for the solar eclipse. It has most of what I've shown you here. It's got the solar motion model, and I've listed them separately if we sell them separately. So we have the sun spotter, which is the second one. We have the motion model, which is the first thing listed there. We have the solar eclipse glasses. And then along with that, we have a clinometer and a compass that we don't sell separately. We have compasses and clinometers, but just not that particular one. And the last part of that is the Starry Night software to show you where those constellations are on any given night and how to view them in what part of the sky. All right, I think that is the last slide. And these are some references. The last two are animations that you might find helpful. It's not good to show animations here. That's why the models are good. The first ones are where I got a lot of the information or the images that I've shared today.
I have a question.
Yes.
And you may have said this, and I think I might have missed it, but how long do the sunspots last?
They usually last just a couple of days.
Thank you.
Anything else? Well, we're really happy that you joined us, and I hope that you enjoy the eclipse. I'm going to travel to Kentucky so I can see it because I'm actually from Indiana, so I'm close. And I hope that you can use some of this information in your classrooms.
Yeah, one more person asking if we can see the glasses again.
The glasses? There you go. They are cardboard, basically like a 3D. Anything else? We good?
Lots of thank yous.
Thank you.
Thank you. I hope you enjoyed it.
Thank you so much.